Okay, let's talk about circulation. We've already talked about this a little bit in class. So the heart is a double pump, okay? And every time your heart beats, there is a function for that, and that is to pump blood. Now, the atria contract at the same time and the ventricles contract at the same time, but they are two separate pumps. The right side of the heart is the oxygenated blood. So the superior vena cava and inferior vena cava and the coronary veins dump into the right atria. This is deoxygenated blood. It travels through the pulmonary arteries, the right and left. There's right and left pulmonary arteries to the lungs to pick up oxygen. Then it goes through the pulmonary vein back to the heart to the left atrium. The left atrium passes it to the left ventricle through the mitral valve. I'm sorry, I didn't say that. The right atria passes it to the right ventricle through the tricuspid valve. So that oxygenated blood then goes through the aorta, and that is the general circulation, systemic circulation. Now, just as a side note, there are right and left coronary arteries that come off the aorta to feed the coronary circulation, and we'll talk more about that when we get to there. The relationship between respiratory and circulatory systems allows for oxygen to be transported to the red blood cells. Okay, there's oxygen, they dump off carbon dioxide, they pick up oxygen, and that happens in the lungs. Now, heart rate and cardiac output. So your normal resting heart rate is between 72 and 80 beats per minute. In athletes, it's usually a little bit lower. For some people, it can be higher, but normal is about 72 to 80 beats per minute. Stroke volume is the amount of blood ejected from the ventricles with each beat. So your stroke volume is, if it's low, there's not enough blood being forced from the ventricles, and if it's high, it might be because of aortic stenosis. So cardiac output is the total volume of blood ejected from the heart per minute. So the stroke volume is the amount of blood ejected from the ventricles with each beat, and the cardiac output is the total volume of blood ejected from the heart per minute. So to get cardiac output, you're going to take the stroke volume times the heart rate, and that is going to give you your cardiac output. When you exercise, you increase cardiac output, right? Because your heart rate goes up. You need more blood, therefore your cardiac output is greater. Okay, so that in a nutshell is cardiac output. Okay, so circulation and for the heart. So the blood supply to the heart has to have a lot of blood supply because it's always working, it's always pumping. You know, you can rest your legs, you can rest your arms, but you can't rest your heart. So it receives its blood through the systemic circulation. So that means the systemic circulation is when the left ventricle forces the blood through the aorta to the rest of the body. There's two branches that come off of it, one right and one left. And the coronary artery takes all the blood, gases, and nutrients in the blood to the internal and external tissue layers of the heart. Because remember, there's three. There's pericardium, there's myocardium, there's endocardium. Coronary veins take the nutrient and oxygen poor blood away from the heart muscle and tissues to the right atrium through the coronary sinus on the posterior side of the heart. That way, the blood all goes together to the lungs for reoxygenation. So the heart has its own circulatory system. Right and left coronary arteries branch off the aorta, and veins bring blood back to the right atrium via the coronary sinus. And this is just a little picture I put here for you so you can see all the different veins and arteries. The heart needs a lot of oxygen, a lot of energy, a lot of nutrients. So you can see it right there. Now, when we're talking about heart sounds, you're listening to what they call lubbed up sounds. Okay, so the first sound you hear is a lub sound, and that is made when the tricuspid and bicuspid valves are closing. So that's your S1 sound. Your dup sound is the second sound. It's shorter and higher pitched, and it's caused by the aorta and main pulmonary artery closing. Okay, so that's your S2 sound. You should always hear S1 and S2. And that brings us to the end of circulation. So I'll be back with the conduction system of the heart.